Alright guys, so today what I want to do is show you how to conduct hypothesis tests using technology. In this case, I'm going to use a TI-83 plus calculator. Of course, if you have a different version of a TI calculator, the process will be very, very similar, if not identical. If you have a calculator that's not a TI, not a TI-83 or maybe 84, then you can probably do this if it's a scientific calculator, but it may take you learning how to do it using another tutorial, or maybe consulting your user manual. So let's get down to business. I have a couple examples here, 3 different examples. So we'll go through one of each of the different types of hypothesis tests we conducted. Now, let's read this first example. It says, according to the U.S. Postal Service, the average weight of mail received by Americans in 2011 through the Postal Service was 57.2 pounds. So all the mail you receive in a year in 2011, on average, it was 57.2 pounds. Okay, 100 randomly selected Americans were asked to keep all their mail for last year. It was found that they received an average of 55.3 pounds of mail last year. Suppose that the population standard deviation is 8.4 pounds. So, in 2011, there was a study conducted, and on average, Americans got 57.2 pounds of mail in each year, with a standard deviation of 8.4 pounds. That's what was known to be true in 2011. So now, 5 or 6 years later, we're in 2016. I guess 5 years later, sorry, in 2016, we conduct a study, and lo and behold, we found that actually of our 100 participants, they received on average 55.3 pounds. So the question is, did we just pick a random sample where they happen to get less than average amount of mail? Or is there a trend in the actual true population mean has decreased? Well, that's a job for a hypothesis test to figure out. So remember what our steps for a hypothesis test were. Okay, step 1 was to state your hypotheses. Okay, step 1. Okay, so remember that is H naught, so H sub 0, and then H either sub A or 1. I'll use a 1 there. So this is your null hypothesis, is H sub 0, that's H naught, and the alternative hypothesis. Now, the null hypothesis, remember, is always your status quo. It's what was shown to be true, or perhaps what a company is claiming to be true. So here we have past research has shown that mu is equal to 57.2. Okay? Now, what is the question asking us here? Let's see. It says part A, find the p-value for the test of hypothesis. Find the p-value for the test of hypothesis with alternative hypothesis. I can't read today. Sorry, guys. Find the p-value for the test of hypothesis with the alternative hypothesis that the average weight of all mail received by all Americans last year was less than 52.7 pounds. Excuse me, 57.2 pounds. I can't read today. I'm sorry. So we want to test to see if mu is actually less than 57.2 pounds. Or actually, we aren't going to test that. We're going to test the null hypothesis, but our alternative hypothesis is mu is actually less than 57.2 pounds. Okay? So we have the null hypothesis is the status quo, and then the alternative is what we think might be going on. Okay, now step 2 was always to draw your null model and to calculate the rejection regions. Now, we're using a calculator, so we don't have to do that. So again, typically if you watch my other videos, I'll draw the null model, which is a normal curve. I'll identify the critical points, I'll shade the rejection regions, all that kind of stuff. But guess what? With the calculator, all you have to remember is that if P is less than alpha, let me get a better alpha, there we go. If P is less than alpha, we reject the null. Otherwise, we don't. Okay? If P is less than alpha, reject null. That's all you have to do with technology, because the calculator, or if you have like a other statistical software package, it's going to calculate a p-value for us. You know, p-values are kind of cumbersome to come by if you're doing this by hand. Take a little bit of work, but if you're doing if you're using technology, p-values are very easy to come by. Okay. Then step 3 was to calculate the test statistic. But for step 3, this is where we're going to use our calculator. Man, can't read or type today. Calculator. Okay, and then step 4 is to make a decision. But we'll get to that as soon as we use our calculator. Okay, so let's pull a calculator up. I have a digital calculator over here that is a digital version of a TI-83 plus. So let's see what we can do. Okay, let's see if we can turn this on. We want to conduct a hypothesis test. So again, this is a TI-83 plus. I know most of you guys have TI-84s now, or TI-84 pluses, but the process will be very, very, very similar. So let's see, make sure I can remember how to do this. Let's see, go to maybe distribution. Let's see, nope. Variables, nope. Stats, yes, stats. Okay, go to the stat menu. Okay, then we want to go over here to the test, and we want to conduct, okay, well, here's a little review. If we know sigma, that is, we know the population standard deviation, we use a z-test. Okay, if we know the population standard deviation, we use a z-test, and we have a large sample size. You know, sample size here is 100, so we have a big sample size here. So we're using a z-test. Okay, now there are different ways to do a z-test, but we don't want to use data. We don't have raw data here. We would use the data feature if we had raw data, but since we don't, we're going to use the stat feature. Oh, let me scroll over, because we're going to enter the values of statistics that we have. Okay. All right. So we need to enter what mu is. Okay. What do we know mu to be? What was previously the case? Well, it was 57. Oh, lost it. 57.2. Okay, what is sigma? Okay, well, the population standard deviation is 8.4. What is x bar? That's our sample mean. Well, it says it was found that the sample had an average of 55.3 pounds of male. And what is our n? Our sample size, our lowercase n, that's our sample size. It says 100 randomly selected Americans, so 100. Now, this is the next step is the nature of our alternative hypothesis. What are we trying to show here? What are we investigating? We're investigating not if there's a difference. That would be the not equals. We want to know specifically if mu is actually less than what is originally thought. So it's a left-hand tail test. Now you have options down here to either calculate and just give you the p-values, or you can draw the distribution. Okay, I'm actually just going to calculate and get the p-values and critical values, the obtained z-values. So hit calculate, and let's see what we have. Okay, so this says we have a left-hand tail test, and here you go. Look, we have a z obtained value. So there's the observed z-value, negative 2.26. And the p-value is p equals 0.011 and change. Okay? So what does that tell us? Now we have to, be able to interpret those results. Now remember, if p is less than alpha, we reject the null hypothesis. So what is alpha? Okay? It says, will you reject the null hypothesis at an alpha level of 0.01? So alpha here is 0.011. That's bigger than alpha. So at a significance level of 0.01, that's a 1% significance level, we actually do not reject the null hypothesis, because P, which is this value right here, is greater than alpha. So that's the first decision, that if the significance level is at 1%, 0.01, we do not reject the null because P is greater than alpha. However, if you use instead a significance level of 2.5%, which is 0.025 for alpha, we find that P is less than alpha. So we would reject the null hypothesis if we had an alpha equal to 0.025. Okay? So let's just write that down for good measure. Now I'm gonna lose my calculator when I start to write here, but let's see here. So Z was negative, Z obtained is negative 2.26. Z observed or Z obtained is negative 2.26. So the decision is if alpha equals 0.01, we do not reject the null since P was greater than alpha. But if alpha was 0.025, we do reject the null since P was less than alpha. Okay? Super easy, guys, if you learn how to use your calculator. And again, there's nothing disingenuous about this. Not cheating. You have to know how to interpret and enter your data and interpret results. Okay? All this is doing is saving you some calculations. So super easy, since and we can always use the p-value approach if we want to. Now notice we didn't compute critical values anywhere. So like if a homework exercise wants you to find the critical values, then you can't really use this process because we have a z obtained. You can use this process to find the z obtained value, but that's not really hard to start with. But this does not list the critical values. It only lists the p-value, which again, the critical value approach and the p-value approach are two different sides of the same coin. They produce the same results. Just the critical value approach is easier if you don't have technology to help you calculate a p-value, especially if you're using a t-chart, okay, for a small sample size, and if you didn't know the population standard deviation. Okay, so that's that. Super easy, super easy. Okay, so let's move on to the next example. Okay. Past records of a supermarket show its customers spend on average $95 per visit at this store. Recently, the management of the store initiated a promotional campaign according to which each customer receives points based on the total amount of money spent at the store. And these points can be used to buy products at the store. The management expects that as a result of this campaign, the customers should be encouraged to spend more money at the store. To check whether this is true, the manager of the store took a sample of 14 customers who visited the store. The following data give the money in dollars spent by these customers at the supermarket during their visits. Assume that all money spent by all customers at the supermarket has a normal distribution. Using a 5% significance level, can you conclude that the mean amount of money spent by customers at this supermarket after the campaign was started is more than $95? So this is a very common application to hypothesis testing. We want to see if our intervention has made a difference. Okay, so we know the status quo here is $95. That's what people used to. That's what folks spent at the store before this promotion started. Okay, then we start a promotion. We take a sample. Here it's 14 customers, and we see how much they spent. Now we want to see if whatever the average of these values is, if that is higher than the status quo of $95, and if it is higher, can we use some statistics to figure out if that's a trend, if there's actually something there, or if that was just random sampling error. Now, this problem right here would take us forever to do by hand. Okay, because we're not given sample statistics. We're given raw data. When you're given raw data, you have to compute x bar. You have to compute s, which is the sample standard deviation, and that takes a long time. Doesn't take a long time. It just takes a little bit of time. It takes you guys a long time. Okay, because we haven't. A lot of times we have not, really visited this subject of finding a sample standard deviation in a long time. So it's chapter 3 type stuff. Okay, now, so this would take a long time because we need a sample standard deviation and we need a sample mean before we can calculate test statistics. Okay, now this is using a t-chart. Now, how do we know that we're using a t-chart, a t-distribution here? Because we don't know the population standard deviation. That's how we know we're using the t-chart. All we know, or we're not even given the sample standard deviation. We have to calculate the sample standard deviation of all of these data right here. Okay, so that would take a little bit of time, but we can use our calculator to drastically cut down on the time this takes. So remember, what is our first step? That's to state our hypotheses. Remember, H naught and the alternative. Okay, so the null hypothesis, that's the status quo. The status quo says nothing's going on. Everything is just going along as it always has been. That is, mu equals 95. That's what we knew to be true before, and that's still how it is now. But the manager thinks his promotion is going to increase spending. So he's hoping that actually mu is greater than $95. Okay, so we have a one-tail test, and this is a right-tail test. Again, usually we would have to draw a null model, identify critical points, and spend 5 minutes here. But all we have to do is say, if p is less than alpha, we reject the null. Okay, alpha here is 5%, so alpha equals 0.05. Okay, so if we get a p-value and it's less than 0.05, that means we reject the null, and the manager's intervention, his campaign, has made a difference. Okay, step 3 is to calculate this test statistic. Well, guess what? Use the calculator. If you have one here. Okay, use the calculator. Okay. Oh man, my penmanship is no good. Calculator. And then step 4 is to make a decision. Now let's pull up the calculator and see how to do this. Okay, go over here. Let's see, turn it on. Okay, so we go over here. Remember, we went to stats and go over to test. Now, we're using a t-test here, again, because all we have is sample data. We need, we do not know the population standard deviation, so we're going to have to use a t-test. And we have a small sample. Small samples usually means t-test. So let's go to t-test and see what happens. Okay, now, we don't have statistics. I don't know what the mean is. This is just, data from our last test. But we have not calculated x bar, and nowhere does it tell us what x bar is. Also, nowhere does it tell us what the standard deviation is. So we're going to have to use data. Okay, now, where does that data live? Okay, it's saying the data lives in list 1. Well, I haven't entered our data yet, so let's quit this, and let's go to list 1. We have done this before in previous exercises, entered data into a list, but let's go back and review. We want to go to Stat menu and go to Edit, that first option. We want to enter all of our data into list 1. So we have 109.15. We have 136.01. We have 107.02. We have 116.15. We have 101.53. We have 109 and 29 cents. We have 110.79. We have 94.83. We have 191 cents. We have $97.94. We have $104.30. We have $83.54. Oh, this is taking forever. 67 and 59 cents. And finally, $120.44. Now, as tedious as that is, it doesn't. It's not nearly as bad as doing it by hand. Okay, so if you want to double check your numbers, you can just go like this, double check all of them, which I would recommend because a lot of times I and other folks enter the data in wrong and you get a little problem. So don't hit clear anything here, hit second, quit. Okay, so we have list 1 saved. Now, all you have to do is go back to our stat, scroll over to tests, want t-test again, and so now we're going to use data. Now what is a mu? What's the status quo? That was 95. That was what was previously known to be true. And where is our data? It's in list 1. Now if we put in list 2, we would need to put L2 there. Let's see. Frequency. What's that? Honestly, I don't remember where that is. Oh, let's just see what happens. Okay. Okay. What do we want to see? We want to do a not a two-tailed test because we don't want to see if there's just a difference. We want to know if mu is actually greater than 95. So that's a right tail test. Okay. So we go down here and calculate and see what happens. Okay. Well, let's see what happens here. We have a we says right tail test. We get a calculated t-value. There is t equals 2.12987 and change. But here's what we really want: p-value. P equals 0.0264. So what do you automatically see? Alpha was 0.05. P is clearly less than 0.05. This is 0.026. So P is certainly less than alpha. Oh, you know what? Oh. Yeah, okay. Yeah, okay, cool. We're good. So N is 14, and looks like we're good here. Okay? Yeah, because there's 14 records. So yeah, N is 14. Okay? So yeah, we have a p-value. So 0.0264. So we can go back over here and say, okay, 0.0264. We can say P equals 0.0264, which is less than 0.05, which is alpha. So we reject the null. So we can say the manager's idea worked. People are spending more money. Okay? So there you go. That would have taken us a lot longer if we were doing by hand, because here would be the process. We have to find x bar, which is find the mean of all those. It's not hard, it just takes a little while. Then we would have to find s, which is the sample standard deviation. Now remember, that would be finding the sum of the x squareds, then subtract off the sum of x squared divided by n, divide all of that by n minus 1, and then take the square root. It's not hard, but it takes a little bit of time. But if you can remember how to use your calculator, you can save yourself a ton of time, especially when you have raw data to work with. Okay? So that's it. P is less than alpha. We found P is less than alpha, so we reject the null. Cool. That's great. Saves you a ton of time here. Okay? Now let's look at this last example. This was when we did 3 types of hypothesis testing in our chapter 9. We did the z-test. Well, okay. First of all, we had the situation where you know a population standard deviation. You know sigma. That's when we used a z-test, and that was the first example. Second example was when we didn't know a population standard deviation. We had to use a t-test in that example, and we had raw data to work with, and so we had to use raw data to calculate a sample x bar and a sample standard deviation. Now, the third type of hypothesis test we did in chapter 9 was proportions. Now, remember, proportions, p hats, and p's and p hats, that kind of business. Now, don't get p proportions confused with p values. P values are probabilities. P hats and p's, those are proportions, the sample proportion and population proportion. So you'll always see the term p value, that's probability. Just don't get those two things confused. Okay, let's see what it says here. Beginning in the second half of 2011, there was widespread protest in many American cities that were primarily against Wall Street corruption and the increasing gap between the rich and the poor in America. Yeah, remember they were called, the movement was called Occupy Wall Street. So it's been, I guess, 5 years now, but I'm sure you guys remember that. According to a Time magazine poll conducted by telephone during October 9 and 10th of 2011, 86% of adults who are familiar with those protests agreed that Wall Street and lobbyists have too much influence in Washington. Assume that 86% of all American adults in 2011 believed that Wall Street and lobbyists have too much influence in Washington. A recent sample of 2,000 American adults showed that 1,780 of them believe that Wall Street lobbyists have too much influence in Washington. Using a 5% significance level, perform a test of hypothesis to determine whether the current percentage of American adults who believe that Wall Street and lobbyists have too much influence in Washington is higher than 86%. Use both the p-value and critical value approach. Now, since we're using a calculator, we'll forget about the critical value approach. We'll use the p-value approach. Same 4 basic steps, though. Step 1, state your hypotheses. Okay, H naught and H sub, I'll say A here, alternative. So, ho-ha, that is alternative, a null, and alternative. So the null here, that is that P equals 0.86. And remember, this is not a p-value, that's a population proportion. Proportion. Okay, so that's what we knew to be true according to a Time magazine poll in 2011. 86% of adults thought that Wall Street and lobbyists have too much influence in Washington. Okay? Now, the alternative hypothesis comes from this second to last sentence. It says, conduct a hypothesis test to see if the current percentage of American adults who hold that belief is higher than 86%. So we want to see if P is actually greater than 0.86% in 2016 as opposed to 2011. Now, we have sample data just off to the side. Let's look at this. P hat is our sample data, and we found that, let's see here, 1780 out of 2,000 believe that hold that sentiment. So what proportion is 1,780 let's see, 780 divided by 2,000. Well, that's 89%. So from our sample data, it certainly appears that more people hold this opinion today than in 2011. But again, we can't say for sure that that is a trend. We can't say for sure that the population proportion of folks who hold that opinion has actually increased, because it could be that we just happen to call 2,000 people that on average held that belief more often than the general population. We can't know for sure without conducting, well, we can't have a good idea. We'll never know for sure unless you collected population data. But we cannot say with any certainty currently if this is a trend or not, that more people have that feeling towards lobbyists and Wall Street today than they did in 2011. So that's step one. Step two, that would be to draw your null model usually. But since we're using technology, all I have to say is if P is less than alpha, we reject the null. That's all I gotta say. If P is less than alpha, we reject the null. If P is greater than alpha, we'll fail to reject the null. Okay, step three, calculate the test statistic. But since we're not using the critical value approach, all we need to do is calculate P, which is going to be using your calculator. So use the technology. Then step four will be make a decision. That's all we got to do. So let's pull our calculator back up and see what we can come up with. Okay? Alright, so let's clear that out. We want to do a a proportion test now. So let's go back to that stat menu and see what we can find. So stat, then scroll over to test. Now we're going to use a z-test, but not just a regular z-test. So not option one, not option two. We're not covering two sample t-test and z-test in this class. Look down here. One proportion z-test. That's what we're looking for here, because we only have one proportion, one sample, and we want to do a z-test. Okay, so hit enter. Now, what is P naught here? Okay, here's where our notation doesn't match the calculator exactly. P naught, that is the population mean. That's the status quo. Okay, status quo is what we know to be true prior, which is 0.86. Okay? Now here's another thing that looks a little different. What is X here? X is the number of people in your sample that hold that opinion. Okay? So the number of people in our sample, it tells us, was 1780. That think Wall Street and lobbyists have too much influence in Washington. And then what is our sample size? Lowercase n, that's always your sample size. And that's 2,000. Okay? Now what are we trying to do here? We want to see not, let's see, here it says, this would be saying that there is a difference, that the proportion has just changed. Well, we're not concerned if it's just changed. This option right here is telling us that's a left tail test saying, has the proportion gone down? But we want a right tail test because the second to last sentence says, see if the proportion is the percent is greater than 86. So that indicates we have a right tail test. So we pick this option right here. Okay. And then we can always either hit calculate or draw. I'll do calculate first. Now, I haven't shown you guys draw, so I'll come back and I'll show you draw. Hit calculate and see what it says. Okay. It gives us a calculated z-value. And just by looking at that z-value, what can you tell me? It's a z-value of 3.86. That's almost 4 standard deviations above the mean. That's guaranteed pretty much to be in most any rejection region when you're doing a z-test. And look at here. Now, don't let this confuse you. That's scientific notation. Okay? That says that you take this number right here and move the decimal place to the right, excuse me, not to the right, to the left 5 times. So that's actually a decimal place, then 4 zeros, then this number. So it's a very, very small number. So clearly that number right there is way smaller than alpha. But let's just write it down. Here, I'm going to write it down so I don't have to keep flipping back and forth. Let's see. Okay, so it's moving the decimal place to the left 5 times. So go over here, we can say P equals 0.0000552. That's our P value. That is certainly less than alpha, which alpha was set to 5%, so 0.05. So P is less than alpha, therefore we reject the null. Therefore, the population percentage has increased since 2011. So the population proportion of folks who think that lobbyists and Wall Street has too much influence in Washington has increased since 2011. Okay? So again, that made this process a lot easier. Now, not that the other way is hard, it's just if you're on a test and pressed for time and you understand how to use your calculator, use that to shave off time so you can make sure to really concentrate on other things that you're having more trouble with, or the homework. Homework. You have a significant amount of homework, so this will allow you to knock some of that out pretty fast. Okay, so use technology again. Use technology. It's there to make your life easier. Okay. Now, one thing I want to do here, I want to show you how what a drawing a picture did. Okay, so we go over here. Let's go back to that same example. We went to a one proportion z-test. Go over there. So everything is the same. 86. That's the population proportion. P 1780 2000 right tail test. Now let's see here. Go. Oh, let me unplug something real fast. There we go. Okay. All right. So we said 2000. Sorry, the tablet I draw on sometimes it messes the mouse up, so I unplugged it since I'm done with it. Okay. So 2000. Now let's say we just go down here. We hit calculate before. Let's draw and see what it does. Oh. Somebody had some stuff in the computer save. Here, I need to do some real fast. Let's clear all that out. Sorry about that. Okay, so let's go back. Try it again. So let's quit there. Let's go back to stats. Let's go to back here, and let's go down here and say draw. There we go. Okay, so it draws a normal distribution for us, and look what it tells us. So it draws it, and it doesn't tell us all the other stuff necessarily, but it tells us the most important information. It tells us the z-value. The observed z-value is 3.8665. Remember that's a very, very big z-value. Remember, with z-values, if you have anything bigger than 3 or smaller than -3, you can pretty much say you're going to reject the null. Because that's almost 4 standard deviations above the mean. The p-value, which is the area beyond that z-value, is going to be, for all practical purposes, 0. So here we see, again, you have to interpret scientific notation here. 1 times e to the negative 4 power. Again, a very, very, very small number. Now, why is it saying 1? I guess it's just not as displaying as many digits here, because we did type in all the same things, I believe. So again, the conclusion is still the same. P, if you round it to 4 decimals, like we would be 0. Well, it would be 0.0001. So again, either way you look at it, P is less than alpha for sure. So anyway, I hope this has been helpful, guys. Again, just to recap, we looked at proportions. Remember, you use a Z prop test, a 1 prop Z test in your calculator to do proportions, at least for our class. For here, we have raw data, so we use the T value, the T test, and we actually had to enter the raw data into a list. Now, if you didn't have raw data and you still need to use a t test, you could use the statistics feature like we did with the other 2 examples and just type in the test statistics. Type in the sample statistics. Okay? And then the first example was with just a regular old z-test where we knew the population standard deviation. And again, we knocked these 3 out super fast using the calculator. And again, not disingenuous at all to use, not even cheating. It's just being smart and leveraging your technology to allow you to do homework and test quicker and in reality more accurately. So, like I said, if you need for a particular problem to do the critical value approach, you'll have to do that by hand because these don't calculate the critical values. But if you need p-values, this is the way to go. So, hope it's been helpful. If you have any additional questions, feel free to shoot me an email or ask me before or after class. See you soon. Have a nice week.